Welcome to this explainer. Today, we're taking a really exciting deep dive into Michael Lanham's fantastic book, AI Agents in Action, second edition. Specifically, we're going to unpack Chapter 3 because it uncovers a true, undeniable paradigm shift in AI development. We're talking about something that is fundamentally changing how AI systems interact with the real world, the Model Context Protocol, or MCP. Look, if you've ever tried to build an AI agent that actually does something useful, you know the absolute headache of connecting it to external tools. Today, we're going to see exactly how MCP makes that headache completely disappear. Okay, let's kick things off with arguably the most painful question in AI development right now. How do we stop rewriting custom connection code for every single tool our agent needs? Before we get to the fix, just think about the current landscape for a second. You build this brilliant, capable reasoning agent, right? But it basically lives in a sealed box. To get it to read a local file, or search the web, or query your company's database, you have to write a custom integration. And then another one, and another one. Before you know it, you aren't really an AI developer anymore. You're a full-time API plumber. It's just a fragmented, brittle mess. Well, here is the absolute game changer. MCP solves this massive integration nightmare by acting exactly like a universal USB-C cable for your agents. It was originally developed by Anthropic, and it's an open standard based on JSON-RPC 2.0. Think about it. Just like you no longer need 10 different weird proprietary chargers for your phone, your camera, and your headphones, your agent no longer needs bespoke code to talk to GitHub or Slack or a local database. It uses one standard protocol to connect to all of them consistently, securely, and efficiently. To really get a grip on how this works, here's our quick roadmap. We're going to walk through the integration problem, break down the protocol itself, look at the ecosystem and its core primitives, explore local versus remote deployment, and finally, finish up with the critical safety measures you need before you hit launch. All right, let's jump straight into Section 1, the integration problem. Building an agent used to mean writing endless amounts of glue code directly into the agent's codebase, literally just to get it to talk to a simple database or API. The book points out that even though OpenAI created a standard for tool use, not all providers actually follow it. So developers were stuck constantly adopting these messy JSON tool descriptions just to suit whatever underlying model they were using. Hosting tool function code right alongside your agents meant you ended up with this tangled giant mix of code supporting a dozen different external services. It was incredibly hard to extend, highly prone to data errors, and frankly, just exhausting to maintain. Which brings us to Section 2, the Model Context Protocol. This is the universal standard designed to abstract all that messy implementation away. Think of MCP as a protective shield. On one side, you have your beautiful, clean agent codebase. And on the other side, you have the absolute wild west of GitHub APIs, custom databases, local file systems, and web searches. Sitting right in the middle, the MCP interface handles all the protocol, API, and format conversions for you. As an agent developer, you completely stop worrying about the specific implementation details of any given tool. You just connect to the MCP server, and the protocol handles the underlying plumbing. It's brilliant. So how does this actually work under the hood? Let's move to Section 3, Clients, Servers, and Services, to check out the architecture. The flow here is actually elegantly simple, broken down into 3 tiers. First, you have the MCP client. Now, this doesn't just mean agents. It could be Claude Desktop, VS Code, or really any LLM application. Second, you have the MCP server. This acts as the protocol handler. It processes the client's requests and sends back beautifully structured responses using JSON-RPC 2.0. And finally, third, you have the services themselves. These are the actual functionalities, like file operations, database queries, web APIs, or even other AI agents. Your client only ever talks to the server, and that server handles the heavy lifting of communicating with the actual service. Let's see how this translates into a fully automated workflow where an agent dynamically figures out what it can do without you having to hard code a thing. Step 1, your agent registers the MCP server. Step 2, and honestly, this is where the real magic happens. The agent calls a function named listTools. It's a discovery endpoint. The agent is effectively asking the server, hey, what can you do? The server replies with a JSON description of all its available tools. Then, Step 3, armed with those descriptions, the agent autonomously decides which tool it needs to execute to solve the user's prompt. It is a completely dynamic system. Every MCP server provides its capabilities through 3 distinct components. Let's define those in Section 4, Tools, Resources, and Prompts. These 3 primitives completely standardize everything an agent might need to access. First, we have tools. These are actionable functions, things like running a web search or executing a database query. Then we have resources. These represent data sources, so think of a PDF document, a specific user table in a database, or even local application settings. And lastly, we have prompts. These are predefined workflow templates that standardize exactly how agents interact with complex tasks. Now, the absolute key takeaway here is about control. Who is in the driver's seat? Well, tools are model-controlled. During a conversation, the agent autonomously decides to reach for a tool when it realizes it needs external info or needs to take an action. On the flip side, resources and prompts are user-controlled. You, the human user, explicitly hand the agent a resource, like saying, hey, read this specific file, or you select a prompt template for it to follow. The tools fuel the agent's autonomy, while the resources and prompts allow you to guide it. Moving right along to Section 5, local versus remote deployment. Let's talk about how you actually connect everything up. MCP is incredibly flexible. You can run a super secure internal process right on your own laptop, or you can connect to a massive external database hosted in the cloud. For a local setup, the agent and the MCP server run on the exact same machine, communicating via STDIO. That stands for Standard Input and Output Pipes. But if you're building something bigger, an agent can also connect to an external remote tool server over the cloud using SSE, which stands for Server Sent Events. To break that down simply, STDIO is perfect for secure, isolated local development. Your Python or Node process just manages the MCP server as a subprocess. It's zero latency and highly secure because it literally never opens a network port. Server Sent Events, or SSE, is what you need when you're scaling an agent across multiple remote clients. It runs as an HTTP service where the client posts requests and the server streams responses back over a long-lived connection. It's multi-client and totally cloud-friendly. And the absolute best part for developers, switching between these two approaches in your code is literally just swapping out the constructor. And because MCP is completely language agnostic at the wire level, we already have this incredible ecosystem of standard servers available to use right now. Imagine this. A Python agent can instantly plug into a Node.js GitHub server, a Slack server, or a Brave search server, and it requires zero cross-language plumbing. The book highlights something super cool here. You can run Anthropic's official file system server using a simple npx command in your configuration. And just like magic, your Python agent can securely read and write local files. It gives you an instant ecosystem of out-of-the-box capabilities. But hey, with great power comes great responsibility. We have to wrap up with Section 6, Safety and Autonomous Execution. Granting true agency to AI fundamentally changes the security landscape. There is a very real divergence in how these systems execute. With traditional LLM applications, think assistants like Claude Desktop, when the AI wants to use a tool, it pauses. It literally stops and asks for human approval. But agents? Agents are autonomous. They process a result, decide on their next action, and automatically execute it in a continuous loop. If an assistant makes a mistake, it stops at one error waiting for you. But if an autonomous agent gets confused, it can rapidly chain 10 bad tool calls together before anyone even realizes what's happening. To prevent those catastrophic runaway loops, responsible engineering demands some serious defense in-depth tactics. You have to ensure your agent hits a solid ceiling before it can do real damage. You need to use tool allow listing, so the agent only sees the exact tools you explicitly approve. You absolutely need sandboxing, running any tools that touch your file system in isolated environments. You must validate the output schemas to stop the agent from hallucinating off of bad data. Put budget caps and rate limits in place so a loop will eventually stop itself. And crucially, you still need human-in-the-loop checkpoints for any irreversible actions, like deleting database tables or transferring money. Remember, security is the floor here, not the ceiling. So now that the messy, painful integration code is a thing of the past, and basically the entire digital world is accessible through one single universal protocol, the only real limit left is your own architectural imagination. MCP has transformed AI agents from isolated, helpless brains in a jar into highly capable, deeply connected systems. By standardizing how agents interact with the outside world, MCP frees you up to actually focus on building brilliant workflows instead of endlessly debugging broken API connections. So with all these tools universally accessible and the right safe boundaries in place, what will your agent build first? Thank you so much for joining me in this explainer on AI agents in action. Happy building!